Okay, so last time we were working on this example, right? The OTMC example, and we created the activity diagram that describes the example, the high-level activity diagram, and we stopped at the identification of the classes. Now we know there is some heuristic that tells you how to at least recognize some classes. They don't have to be final, and not everything that like has this description applied to it is an actual class. But these are just things to think about. Okay, so not every noun in the problem description is a class, but nouns are generally good candidates as something to start thinking about. All right, so if you remember this problem, now what can be classes based on the description here? Now, actually, when you have a noun could be a class or could be an attribute. So if it's a noun that has like some sort of a property of something else, so that something else is the class, and the noun, which is the property, is the attribute of it. Okay, so can you recognize classes based on that description? So what are the classes that we can recognize here based on the problem description or the problem statement? So nouns, concepts, sometimes actions if they're described as a noun. So what classes can you identify in this? Yeah, we do. Yeah, there's a membership. So game is one of the things that we are interested in, but the general type is what? So the membership is the connection. So let's say we have game. We put game as a class. Okay? We have a game as a class. And then we have a member. The member wants membership with game. So we have member, we have membership, and game. But we have other things that are similar in type to game, right? Other memberships that we have here. We have coffee membership, wine, beer, cigars, flowers, and computer games. So all of these, depending on the details, now this problem description doesn't give us enough details, but depending on the details, when you get more deeper into the problem, you may feel like, okay, a game should be a class in itself, and there should be a super class that is a service or a product that a game is a subclass of. Or you might decide that actually game is an object of the service class. It doesn't need to be a subclass. Okay, depending on the problem. Now here we just a suggestion to start with is that we have the member and we have the service. That these are the two most obvious classes. Okay. Now membership may not be as obvious. It depends. Like it might become obvious when you start to add details to the relationship. So, for example, if we want to have the attributes of the member, name, email, mailing address, and credit card, these are the things that are mentioned. And the action that would be related to the member, okay, is to add membership. So to increase that, add membership with a service. Now the question was, if we want to add membership, where would we put the quantity? Now the quantity doesn't belong to the member class, and it doesn't belong to the service. It belongs to the connection. So that's why it is its own class. Sometimes they call this an association class. Okay, so association is the relationship. So a class is just represents the relationship, and there are some attributes and some functions that we need to add to this relationship. That's why I created it as a class. Okay. Now, if we want to represent some of the behavior here, so based on the description, we need to check availability, okay, reduce stock, refill, and here the behavior or the functionality related to membership is to fulfill. Okay, so perhaps to fulfill would need to check availability first, right? And if there is availability, we would need to reduce stock. So if we want to get to the details of one of the functionalities here, like fulfill or add service, we're gonna need to represent some interaction between different objects of these types. So let's say we have a member, John, membership with video game, and quantity of 2 CDs, for example. Okay. Now, if we want to call each of these are object of like one of them is object of a class. So John is an object of member. Game is an object of service. John membership in game is an object of membership. Now, if we want to call fulfill on this object, we need to specify the details of how this function is going to operate, right? Now, this might need another model. Obviously, this interaction, this behavior cannot appear on a class diagram, right? Any interaction, anything dynamic, anything that involves steps is a dynamic model, and the class diagram is a structural model. So structural model is just static. Anything dynamic needs a behavior model. An example behavior model we worked with the last time was the activity diagram, right? Now, if we are going to start looking into objects and interactions between objects, like what I'm trying to describe here, how would the fulfill interact with the service? Now, this is an interaction model, and one of the interaction models that we can use is the sequence diagram. So how would the sequence diagram of this look like? So here's an example. So let's say here I called Alice and Cloud. Like the example I mentioned verbally was John and Game. It's another object, okay? But this object, Alice membership with in coffee, is an object of the membership class, right? So Alice is the member of is an object of member. Coffee is the object of service. Now, if we call the fulfill method, this would be the activation of the fulfill method, which means that pretty much the code that we want to write inside the fulfill method would be represented here. Okay. So the first step, we need to call get mailing address from Alice. Okay. And then what returns? We may or may not need to add the description of what returns on the arrow. If it's obvious, then we don't want to add it because we want to reduce the clutter on the diagram. Okay. So here it's very obvious we are trying to get the mailing address. It's very obvious that what returns the mailing address, so we don't need to write it. Now there is a self call, so a call to the get quantity, which is part of the same object here. So it's not a call to another object, it's a call from within the same object, recursive call or a self call. All right, now here we get the mailing address, here we get the quantity, and then we check the availability with the coffee object. Check the availability of the quantity. All right, and depending on what returns, now we see here that here's an alternative. So that would be translated into an if statement. based on what returns. If the quantity available, then reduce that quantity from the stock. Otherwise, request a refill. Okay? So does that make sense? In terms of, this is the kind of interaction that we would need to translate into code. Does that make sense? Okay, now when we get to translate it into code, how would that work? Now, when you define the membership cost, since the membership cost needs access to the member, and it also needs access to the service, then we need to send the member and the service as objects, okay, to the membership cost. And then when we get to the fulfill, whenever there is a call, so depending on what you see here, there's a call to the member object or a message sent to the member object that is get mailing address. So now we have a reference to that object that's called the member here. This is the reference to the object. Now we can use that reference to send the message. Can you see the connection? Now, if there is a self call like this one, we can just call the function, but if we want to have it more clear, we can just use the self pointer, because the self is a pointer to the self or this object. All right. So every message here would be translated into a call through the object that we have in the code. Okay, is this clear? Is this clear? Okay, it will become easier by practice. The more you practice, the easier it gets.